So the problem here is about frequencies is ask you which electromagnetic wave has the highest energy out of these four, 1, 2, 3, 4. And so if you don't understand what's going on in frequencies, then it's kind of hard to picture or visualize it in your head. So go ahead and ask yourself, what does frequency mean, right? What is frequency? And well, frequency is just how frequent something happens, how often something happens. So you're trying to figure out, when the question asks you about frequency, you're trying to figure out how often something happens. So what is that something? And the best way to explain this equation right here, the frequency equals the speed of light over the wavelength, is if you think about the sine wave. And if you look at the sine wave, it has this shape, and we know certain values on this shape. We know that this peak right here and that peak right there are going to have the values -1 and 1, and the value of the neutral axis is going to be 0. And we could use that information. We could say that -1 and 1 in electricity are going to be your on switch, and 0 is going to be your off switch, right? So to use that information, to use this, if we know that, then we could say that we could start sending signals or messages to other people or computers, other electrical devices. And so the way the computer works is that it uses 8 figures to send a message, right? Any message. But this is the way the computer sees. It doesn't know any human language. That's their language, on and off. So that's one message, one expression for the computer to understand. So in order for us to send an actual message to each other, for us to understand, we need to send many of these sine waves at any given time. In 1 second, for example, suppose that sine wave is 1 second long. So we want to compress those signals, and we want to send more in a given amount of time, right? So the problem is that in order for us to increase the sine wave, we need to increase the frequency, we need to increase the power to produce that compression. So we have the formula here that says the frequency is equals to the speed of light over the wavelength. And now that you get the logic that we have to compress and we have to use more energy to send a signal at a higher frequency, then we can start calculating which of these is actually higher. So some of the units that you should know is your metric system is tera, your giga, your mega, kilo. I'm just going to write amp for meter. Your milli, nano, and your pico, PM. So that's 10 to the -12, 10 to the -9, that's 10 to the 0, 10 to the -3, 10 to the 3, 10 to the 6, and I'm just going to leave it at that. Those numbers. So the first one, they give you a 2.5 picometer. So if we're trying to find a frequency for that, it's going to be 3 times 10 to the 8 meters per second, or 2.5 picometers, which is 10 to the negative 12. And if you compute for that, you're gonna get like 1.2 times 10 to the 20 hertz. Because the units for frequencies are hertz, 1 cycle per second. And so that was A. For B, your frequency is 100 megahertz. And since it's already in megahertz, so if you look at mega, that's 10 to the 6. So it's 100 times 10 to the 6 hertz. Your C is going to be 500. Remember, just the speed of light. 10 to the 8 over 500 nanometers, and nanometers is 10 to the 9th, 10 to the negative 9. And that's going to be 6 times 10 to the 14 hertz. And the last one is D, frequency. It's equals to this one. They just give you the hertz, 10 to the 17th. So obviously, out of the four, the first one has the highest frequency, which means that it has the most compression of sine waves per unit of time. So in order for you to use the most compression per unit of time, you also will have the most energy to produce that compression. All right, hopefully that helps.